Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
A very good day to everyone, and thank you for joining. Welcome to the ITU AI and Machine 5G Challenge webinar session. My name is Thomas Baskol from the ITU, the International Telecommunications Union. The Machine Learning in 5G Challenge, and currently we are talking about the tinyML Challenge. It's creating a community of network-related participants. This time around, we are solving problems that are related to tiny machine learning, or HML. And today's webinar, we are going to introduce 3 interesting problem statements that are related to the tinyML challenge. So the title of this webinar is 2023 tinyML Challenge Webinar. Quite simple and straightforward. In today's session, as I already pointed out, we have 3 topics that we are going to present. We have this next generation smart weather station, which is one of the problem statements for the 2023 tinyML challenge. We also have high performance and scalable tinyML related solutions. These are competitions related to crop disease detection as well as wildlife monitoring. So we are counting on you to help engage during this webinar, but also to interact with us, ask some questions during the sessions, and of course, we have interesting speakers. So the first speaker is Marco Zennaro from ICTP. I would like to welcome Marco. Good afternoon, Marco.
Good afternoon, and thank you for inviting me here.
Yeah, so the floor is yours. You're the first one to speak, so I give the floor to you. Jona, you can share the screen and we can start the presentation.
Excellent. Good afternoon. So my name is Marco Zennaro. I'm a research scientist at the International Center for Theoretical Physics in Trieste, Italy. And we're partnering with ITU and with our CSEM colleagues from Switzerland on this tinyML Challenge 2023. Next slide, please. So my task here is to introduce tiny machine learning. I am sure most of you know already about this technology, but just to give an introduction. Next slide, please. tinyML is the intersection between machine learning and deep learning and embedded devices. So when we're talking about IoT, we're generally having in mind devices that send information on a regular basis to some cloud service where there's an ML application that makes sense of the data. Well, in tiny machine learning, we're using machine learning on the IoT device itself. So it's part of what is called edge computing. So making the computation as close as possible to the final user. And this is a technology that we're using on a daily basis, I would say, when we're using our smartwatches. So when we're using our smartwatch to communicate, asking, hey Siri, there's a tinyML application running on the phone that activates the phone when that specific keywords are pronounced. Next slide, please. There's a number of applications of embedded machine learning or tiny machine learning in the development world. So just a few examples here, considering SDGs 2 and 3 about zero hunger and good health and well-being. There's Nuru, which is an ML application running on mobile phones that can detect plant diseases. And again, this application runs an ML model on the mobile phone itself. So there is no communication aspect in that. There's applications where tiny drones use tinyML to provide a pesticide information. So actually this kind of application can reduce in a significant way the number of spraying, the amount of spraying of pesticides. And then there's an application that we developed at ICTP about identifying mosquitoes by using their wing beat frequencies. Next, please. If we're considering SDGs 14 and 15, so life on land and below water, there's again a number of interesting tinyML application. There's an application to detect issues in forest, so poachers and so on, by using the sound. And in that case, they use recycled smartphones and solar energy. There's application that can help understand how elephants communicate and what kind of activities they're engaged in. There is an application developed by Google where they use tinyML on buoys using hydrophones to alert ships. Next slide, please. And talking about to climate, which is related to our weather station application, so SDG 13, climate action. There's a number of applications where they use a greenhouse gas emission data set through some intelligent sensors. It's called Ribbit. It's a network. There's application where they use tinyML on really tiny robots to be used as artificial pollinators. And there's some smart air conditioning system that reduce energy in buildings. So this is just to say that tinyML is a new technology where we use machine learning on embedded devices, and there's a number of applications that can tackle the SDGs. And the one that we're going to hear from Jona in a second is a very useful one for climate action. So that's all from my side. Jona, if you want to take, please.
Thank you, Marco. Let's move to the.
Oh, I missed one slide. Sorry.
You forgot one.
Yeah. The slide is about an activity that we set up 3 years ago called tinyML Academic Network. So we have about 50 universities all over the world that are working in tinyML research with an impact on society or development. And there is a website called tinymledu.org where you will find lots of training material freely available, so videos and slides. So if you want to learn more about tinyML, there's a lot of material already available. And now the floor is yours, Jona. Thank you.
Okay, thank you. So, Matteo and we are here today to present for you the Next Generation Smart Weather Station Challenge. And just as last year, the goal is the same. So we aim to build a low-cost, low-power, reliable, accurate, easy to install and maintain weather station without any mechanical moving parts to reduce maintenance costs, and that is able to detect wind and rain conditions based on local tinyML processing on the device. And for this challenge this year, we have a very nice sponsor. We have Edge Impulse, who is sponsoring the first 3 prizes. We have a nice timeline. So we launched this challenge beginning of August 4th, and it will run until November. So still plenty of time to participate and to register. So if you want to have more information, probably you already found the website, but still in case, here is a QR code that you can scan to get more information. So we will work with 3 checkpoints. So the first one is about next week, where we invite you to write us a proposal. It can be a 1-pager or 2-page document where you just explain what you aim to do in this challenge. And if you submit it to us, we will analyze, we will give you some feedback, and then you will also get some bonus points in the evaluation later on. We have a second checkpoint in September 22, where you're invited to send already your model you have until then, together with a short analysis of what you achieved by then. And then the final submission is for November 10. So what do we aim to do? So it all started last year with the tinyML Challenge 2022, where we exactly had the same goal as I just presented, and for which we, as CSEM, a Swiss Research Institute in Switzerland, we designed Aurora. And Aurora is a weather station which requires low maintenance, as it has no moving parts, it is low cost, and it has all the processing locally, so we don't need any cloud. We were awarded last year with the first prize, and so therefore we are now co-organizing this challenge because we believe that with our weather station we can get a bigger data set and we can help you to create better models. So the big picture is as follows. So we have microphone data that we will measure with a microphone, and we have an ambient sensor that can track temperature, humidity, and pressure. And this is fed into a small microcontroller who then uses a model that is trained on the dataset that we will provide and that can detect the intensity of wind and rain in an accurate manner. The components we envisioned last year are the following. So we have a low power microcontroller. We have like the environmental sensor for Bosch. From Bosch, we have a battery to make it a self-contained system. And we printed the housing with a 3D printer. And as you can see in the table here, the cost is rather small. So this is without any economies of scale. So it's really to build one prototype is below 100 euros. That was what we had last year. Now this year we did better. We helped you to get better data, as we are now adding a reference weather station, as you can see on the slide on the right, to give us the example. So we have a reference that we will read in with our microcontroller, and we will log together with the microphone data, such that you have microphone data and you have like the reference weather station information, so that you can do really supervised learning. So we improved also the readout of the sensors of this reference system, because there was some noise on the signals, and we improved that. We also added a solar panel, so we don't need to recharge batteries. It's really fully autonomous. And we also added wireless communication, such that we can get the data in real time, and we don't need to go there and replace SD cards now and then. The architecture for the data acquisition looks as follows. So as I just explained, we have our mechanical weather station, which can track rain intensity, wind intensity, and wind direction. We feed this to our data pre-processing block. Then we also have the environmental sensor that we also feed to it. Then we have the solar panel with the power management unit that will decide how to charge the battery. And then we have a small microphone on the board that will give us information in raw PCM format, so it's not compressed. We have 24-bit precision, and the sample frequency is 16 kilohertz. So we will feed this all to the data pre-processing block, which will basically aggregate all the data, store it locally, and then communicate it via Wi-Fi to our central server, from which we will share the data set with you. And this architecture is really used to create labels for the database. So to have a database with both audio information and a reference for the wind and rain intensity. So now I hand over the floor to Matteo, my colleague, who will present you the website that we built especially for this challenge.
Yeah, so for the sake of the challenge, we decided to create a website where you can find general information about the challenge. You can find as well information about the evaluation criteria and the different deadlines, where you can find details about what we expect for each submission. You can also find documentation on how the data is formatted in the binary files from the dataset. And on this website, you also have emails that you can refer to if you have any questions, any issues with the documentation, with the website in general. Feel free to send an email, because we're here to help you and support you throughout the challenge. And then we have a very important page on the website, which is the dataset page, where you can find and download the different files that compose the dataset. So to download the files, you need the password, and to get the password, you need to first register. So you can see here that the files are grouped by week and by station name. Here on the website, you can see as well that there's an important feature called changelog, where we will keep track of all the changes we do in the website or in the documentation. So please keep an eye on this throughout the website, throughout the challenge, because we will log all the changes there. And yeah, that's it for me. Thank you.
Okay, thank you, Matteo. And I also would like to say that we also have a dashboard in place where you can see the current weather conditions that we have for the first station that we installed here in Switzerland. Normally, throughout the challenge, we will install more stations. We will see how that goes, but for now, we already have one station fully operational and generating data. And as you can see, we already have 23 gigabytes of data available for you, which is already, I think, a good start to start with this challenge. Then, yeah, so this is the deployment. So currently we have one station in our headquarters, and we aim to extend it to the other sites of CSEM in Switzerland. And for the evaluation, I would like to mention that we will have like a test bench to evaluate. And to do that, we will keep a test set that we won't share with you during the challenge. And at the end of the challenge, we will use this test set to evaluate your model. And since every model can be a bit different, the input can be a bit different, the output is a bit different, we propose you to provide us with a pre-processing script that will read the test set in a certain format. We will communicate you with about it, and then also evaluate its model on a certain set of metrics that we also will communicate to you, and that you need to implement and send to us together with the model, such that we can quantify the performance of your model. And some metrics that we will take into account are accuracy, the memory footprint, so how much space does it require, the energy consumption, the latency, so how long does it take to take one inference to do one measure, the prototype, so whether you build a nice prototype together with the data set that we provide, and as well as the documentation and the code quality that you will provide at the end. So that's all from our side. I hope it was a bit clear, and we are very open for questions that we will answer, I think, at the end of the webinar.
Okay, thanks a lot, Jona and Matteo, for presenting the Smart Weather Station. Right now, we are going to the next part, which is part 2. And in this part, I'm going to introduce or just give a brief overview of the 2 other problem statements that we are tackling this year as well. So for these 2 problem statements, they are titled Scalable and High-Performance tinyML Solutions. And what we are focusing on these scalable and high-performance solutions are on 2 specific topics. The first topic is on plant disease detection. So we'd like to use tinyML solutions to detect crop diseases, which is one of the most important aspects in terms of agriculture. And next one is on wildlife monitoring. And if you can see, both of these problem statements are related in the computer vision space. So utilizing tinyML in this space would be quite effective and efficient. And we hope that most of you are going to take on these problem statements as well. In terms of the prizes, you can see we have 3 prizes. The first prize is 500 Swiss franc for both. So each one, sorry, I shouldn't say both, but for each. So if you are participating in the plant disease detection, if you win, you get 5,000. The second one, sorry, 500. The second one, 300. The third one, 200. If you are participating in the wildlife monitoring problem statement, the prices are also in the same category. And in terms of the timeline, the proposal checkpoint should be 31 August next week, so it's not 25. So this should be updated. We will update it, but I think on the website it's already updated. So by next week, Thursday, you should submit your proposal checkpoint. And on 22, then we have the model checkpoint, and then the last one will be November 10, final submission of the solutions. And you can find more information on the 2 QR codes. These are for each of the problem statements that we are talking about. If you can go to the next. Okay, so let's talk a little bit about the plant disease detection. Why is it important? Why are you tackling it? Currently, in most of the economies, I think everyone eats, and we rely on agriculture, and agriculture plays a critical role in our everyday life. First, we are talking about food security, which is SDG number 2. And of course, agriculture also helps us in terms of in most of the economies. People plant, grow crops, and sell for money. So it helps most of the countries in terms of their economy, or most families for their economy. And the diseases that goes on to plants, they cause significant losses in terms of food production, but also in terms of the number of gene pools for the plants itself. So if we don't have different varieties of plants, if one gets a disease, it's going to wipe out everything, so which is not good. We want to avoid these kind of problems. So early diagnosis of the diseases for plants, and if we can accurately diagnose these diseases, we can minimize the losses, and also we can enhance the quality and the amount of food we produce, as well as we can minimize the economic losses. So this is the rationale for this problem statement. We would like to achieve SDG number 2 on food security. At the same time, we want to enhance the quality of food that we are producing, of course, by using techniques that are accurate, but also that are cost effective. So we believe that tinyML brings this cost effectiveness because it's low cost, low power, but of course reliable. So next slide. And in terms of the wildlife monitoring, we have seen a dramatic decrease in terms of the animal diversity. And of course, every day we see news that some species are endangered. We have a lot of species that are going to be wiped away in the next maybe 50 or 100 years, which is not good news. Because wildlife, maybe people don't know, they just think about wildlife like, okay, we are going to park for safari, that's all. But of course, they are necessary in other ways. They prevent drought. They also help us to prevent creation of new deserts, help to prevent fires as well as floods. So there are a lot of, I would say, significance or importance of the wildlife. But also, in terms of the food system, we rely on animals, for example, bears and bees, to pollinate our crops. So if we don't have the bees, for example, we are going to be wiped out in no time. So we really need to monitor these, manage them, and make sure that we have health wildlife that can help our planet. But unfortunately, the ways that people are managing the wildlife currently is people have to go into the field, monitor the animals, see what they are doing, and report back. So this is time-consuming, labor-intensive, but also expensive. Of course, as we have machine learning currently, people have started using machine learning, but it's quite expensive because the technology that people are using is called camera traps. So these are the most used, but they are not as cost-effective. and yeah, the deployment is not that much. So we need low-cost solutions again. So tinyML is one of the best solutions that we have currently. So that's why we are also tackling on this problem statement. Now, let's go to the next. So for these two problem statements, we have shared open datasets. These are datasets, for example, that have been collected by other people around the world who are researchers or just interested in this kind of topics. So we have shared these open datasets, but also we encourage you to be resourceful, to if you have a means to collect extra datasets on your own, you can add to enrich these datasets, but also you can share the datasets openly, because we encourage open research, open innovation, to make sure that we come with better solutions for the betterment of everyone. Next slide, please. So in terms of the evaluation for both problem statements, you can see on the website, we have like in-depth description of the evaluation, but here I'm just putting it into two parts. So we have quantitative and qualitative. So the quantitative, we have, for example, accuracy, size and complexity of the model, efficiency, latency. These are the quantitative. And in terms of the qualitative, we have scalability, robustness, and documentation. Now, why we are talking about scalability? If you imagine a farm, someone is having a big farm, is in terms of maybe hundreds of hectares, or if you talk about wildlife, maybe national parks, they are in the hundreds of thousands of hectares. We don't want a solution that is just one simple machine that can work on one site. We want to scale across different areas, a large area, but also your solution should be able to, for example, monitor for wildlife, monitor different types of species in different habitats, but also different image qualities. In terms of the crop disease detection, we also want to monitor different types of crops, different types of diseases, and of course, in different types of environments. So you should be able to imagine these kind of aspects when you are designing or when you are coming up with your machine learning solutions or tinyML solutions. This is one thing I wanted to highlight, but in terms of the accuracy, I think everyone knows what is the accuracy of machine learning model. In terms of the complexity, the size, I think if you are deploying a machine learning on an embedded device, you will have to maybe restrictions in terms of the size of the RAM or the flash that is available on your hardware. And in terms of energy, we want to consume as minimum power as possible while maintaining high performance. So high performance, low energy, but also low latency in terms of processing and classification on different tasks. These are some of the aspects that I wanted to highlight. And of course, if you have questions, you can send them to us and we'll be able to respond to your questions or comments. And of course, at the end, we would like to have working prototypes from you that we can evaluate so that we can find the winners, and hopefully we can scale these solutions for better. Next slide. In terms of the milestones and checkpoints, yes, I mentioned. So the proposal checkpoint is next week, August 31, and then after 3 weeks, September 22, we have model checkpoint. So please make sure that you submit your solutions or your proposals and the model checkpoint in time, and you will get feedback, but also you'll get bonus points towards the final submission of your solution. Next slide, please. Now, good news. We are happy to announce that Seed Studio and Arduino are providing hardware support, but it's not for everyone. It's for people who are deserving. Not everyone is deserving, but of course there are some people who like hardware to finalize their solutions. So you can submit your justification why your team needs hardware support. And of course, you can submit to Seed Studio. We have the link on our website, on the problem statement description. Please submit your request to Seed, and they will evaluate together with us. We'll find who deserve to get this hardware. It's not much. It's a few number of hardware kits, so not everyone can get. But I hope we give out some to deserving teams. And Arduino is also providing their tinyML kit. So you can send us an email and we'll be able to we will find which teams can receive this hardware. So we would like to thank Seed Studio and Arduino for providing these hardware to teams. I know last year we had problems. Some teams couldn't submit their solutions because they lacked hardware. I hope this time around, it will be easy for teams to have a working prototype for their solution. And also I'd like to thank H-Impasse for providing sponsorship money to the Smart Weather Station. So all the prizes for the Smart Weather Station problem statement are coming from H-Impasse. So thanks to H-Impasse. And to participants, if you want to, for example, train your model quickly, you can check out H-Impasse. They have a nice solution for that. Next slide. Okay, so thanks to our co-organizers who has been helpful to make this webinar, to make this challenge get going, ITUAI for Good, ICTP, and CSEM. So thank you, everyone. And we can go now to the discussions time. So I would like to welcome my colleague, Vishnu. Hi, Vishnu. Good afternoon.
Great. Thank you so much. Thank you so much, Thomas and Jona and Matteo and Marco. Great presentation. It's nice to see open data set. That, Thomas, basic question, there have been a lot of requests for the slides and recording. So I believe they will be made available, right? We will make them available. And maybe one more request to you, Thomas. If we could just put the problem statement link in the chat for others. I mean for everybody. That will be nice as well. There are some questions on the data set. I believe that will answer. I mean the link to the problem statement will answer that. Thank you so much. Then I have I have a question for maybe that wonderful portal from Jona and Matteo. Thank you so much. That looks totally wonderful. I was looking at the portal, Aurora portal. Thank you so much. Let me take this one from Blessed. What is the duration of each audio sample of the rainfall recordings provided by you, please, Jona?
Okay, so the duration of every sample is 1 second. So basically, what we do in our devices, so we have one second of audio. This we do 4 times after each other, so we have 4 seconds in total, and then we send one Wi-Fi packet to our server, which takes a little bit of time, during which we don't have like the audio data, but then we start again with these 4 seconds. So normally we have around 4 seconds of data, and then we have around below 1 second transmission time, and then we sample again. So it's really a continuous measurement, and in every sample we include also the reference weather station data.
So it is 4 seconds of data followed by maybe 1 second of transmission time. That's what it is.
Yes, it's just that on a packet level, we like the audio is guaranteed to be continuous in 1 second. So we do 4 packets of 1 second, and then we send it.
Okay, great. Thank you so much. Then maybe while you are here, the portal, is it? I believe it is real time, no? I mean, you have installed it and it is showing real time data, isn't it?
Correct. Yes, it's showing. We update it every hour. So the data in the dashboard. Maybe I can show you if you want. Maybe we can go over it together. I think you don't see my screen anymore. Is that correct?
Yeah.
Okay, so I'll share window. Okay. So this is the portal that we built for this challenge. So here you can see, okay, this is the installation at Neuchâtel. Then we have a nice description. Then with the goals and a bit of more information on the evaluation criteria, how to register, and then also the different milestones that we planned. And what is interesting for you, I think, is the documentation, which is provided by Matteo, my colleague. So he spent a lot of effort for writing this documentation for you so that it's clear. So please let us know if something would not be clear, then we can update it and we can improve it. But so here you can see how the packets look like. We have the audio sample. So here every audio sample is 1 second. We add some ID, we add a timestamp, so we know when it happened. We add the environmental sensor, we add the information from the mechanical weather station, and then a checksum for to control the validity. So here is more information on how it looks, the file structure, how it is organized. And then here in the dashboard, here you can see in real time what is actually going on station 1. And so here you can see that it's lastly updated 5 minutes ago. And here you can see the temperature. So currently we have 27 degrees, a little bit of wind, not a lot of rain for the moment. This is because it's summer, of course, and we hope we will get some rain. So here you can check the humidity values, the rain values. So in the last 24 hours, we didn't have rain. Then we have wind speed. Yesterday night, we had a lot of wind, as you can see here. And then we also have the wind direction provided by the mechanical weather station. So this is all being there for you and being updated. And of course, this data is just to show you, if you download the data set, you can get the real values. And the real data set is here. So yeah, we have around 23 gigabytes. As Matteo explained here, we also have a change log. For example, we implemented the checksum byte, which was not there in the beginning. So you can check here exactly at what time it was implemented. So if you take data from past that time, you should consider it in decoding it. And then here we will release like the data for every week to keep the file size reasonable. And yeah, we will try to update this in real time, or almost real time, let's say.
Sounds good. Thank you so much. Yeah.
Yeah, if someone has more questions on this portal or the dataset, feel free to ask.
Yeah, actually, the link to your portal is in the chat window. The participants can look at it, and they actually I was looking at it while you were speaking. It's a wonderful effort. Thank you so much. And the data set is quite useful as well. I think it's very clear. Can I ask you, Jona, the accuracy? You talked about accuracy and you talked about latency. If I remember right, yeah. So yeah, both of it are in your list. Can you tell the participants what how do you want them to measure the accuracy, and how do you measure accuracy? And because in this particular case, you might have time series data, and you might do predictions for the for a time period. So that's why I'm asking, how do you measure accuracy in this case? And secondly, latency. So how do you measure latency? Is it from when do you start measurement for latency, and how do you measure latency? Could you explain this, please?
Yes. Okay. So for the accuracy part, yeah, it's true. We are working with time series, and we don't want to set a constraint on the participants to which duration they will they will take the time series, because what you could do is, for example, take data for 1 minute and then give one output, and then you can have a very accurate result. But of course, it will be a very slow result, because you have to wait a long time before you output the result. So that's exactly the trade-off we would like to analyze when the participants submit. So the accuracy, since we have an imbalanced data set, most probably because we don't have a lot of rain, or we have more clear sky than rainy. So therefore, we will work with precision and recall metrics, which is more meaningful than just the mean average error. And for the latency, so when does it start? So basically, it will start for the latency here. What I mentioned is basically the latency for the model. So that's one part. And then the latency for the pre-processing. So for the pre-processing, what you can do, you can aggregate a lot of data, which will take more time, so will increase the latency. And then you have the latency of the model, and the latency of the model is you pass the data, you run the inference, and you check the result, and that's the second part. So this latency consists of two components.
Okay, yeah, that exactly answers Blessed's question. Thank you so much for answering that. Let me ask Prithvi's question. Prithvi is asking about expected output. I believe you have already answered that, but maybe let me ask about the documentation and the characteristics of the prototype, because both of it you mentioned in your presentation as well. So what are the types of documentation which will win this challenge from your experience as well, Jona? And what are the characteristics of the prototype which will win the challenge, please?
Okay, for the documentation, a tip that I can give is be as detailed as possible, and start with documentation not just at the end, because at the end probably you don't have time anymore. Do it really from the beginning. It will help you also to make your design better and the model better, because we all know in machine learning it's sometimes a bit of trial and error, and then you don't know what you tried before. So start with documentation in the beginning and try to document the approach, how you did it, what steps you did. You could also add what you tried and did not work. But yeah, the most important thing is how you came to this result. Yeah, that's for us the documentation part. For the prototype part, what we would be looking for is the following. So we will provide a data set with a weather station from ours. The idea is not to take away the creativity from your side. So we really encourage you to be creative, to build your own design with your own microphone, and try to, for example, pre-train on our data set, calibrate it on yours, and show the inference in real time with a video of a demo that shows, for example, if it's clear sky, it says it's clear sky. If it's raining, that it says raining. This is what we are looking for.
I see. Okay, yeah, thank you very much. Just to be clear, the inference that you want from the participants is how far into the future?
Okay, here could be a misconception. So because it's not that we aim for prediction. So it's not that given the current weather, what will happen next. What we are currently focusing on in this challenge is really to detect if it rains and how much it rains currently at this period of time, in addition to the wind. So how much wind is there?
Understood.
So
thank you very much.
Yeah.
Great. I think that's an important clarification. I believe that was the same parameters last year as well. I think I had some questions on the data sets, but I think the links to the data sets are quite clear now. I would say the participants can look at the data sets, a link, and decide. Can I maybe ask you, Jona, about publications and presentations? You had a wonderful presentation last year as well, and in the workshop as well. Can you tell us about your experience with publications and presentations post the challenge? So you have the challenge, you have opportunities not only in winning the prizes, but also in publications, getting some feedback or opportunities to discuss with the experts and showcase your solutions as well. Could you tell us a little bit more about your experience, please?
Yes. So we were very grateful that we were invited to attend the AI for Good Summit in Geneva earlier this year in July, where we got the opportunity to showcase our weather station at this event. And some of the lessons that I learned is don't be shy. Please talk with people that pass by, and really try to find ways to connect. Because there might always be a different angle than what you would think in the beginning. And then if you look at their application, then you see, okay, this might also work for them. So this is something I learned. And regarding presentations, try to be clear, try to be better short and clear than long and not clear, in my opinion. So try to be concise and really to the point, and show what you did, and show the motivation, show the passion that you put in, because that's the reason why we are going further with this challenge and this project, because we are motivated, and I hope you are as well. And that's what we would like to see.
Thank you so much, Jona, for sharing that. I have one question in the chat, but I want to ask Marco something before he runs away. Marco, can you tell us about hardware? I know we had a very good support from you. One of our teams needed participant teams needed hardware, and you stepped in to make sure that they had it. We are extremely grateful for that, and thank you so much for that support. But now, in this challenge, what is your opinion about how the participants can get hold of the hardware to do this? What are their opportunities locally from your hubs, if at all? And how can they get enough hardware to?
That's a very good question, Vishnu. I leave the hardware arrangement to Thomas to comment on. What I can tell you is that as participants can use Edge Impulse for their modeling, they will get some of the results that Jona presented already in that tool. So even if they don't have the hardware at hand in their labs, they can still get a feeling about the memory usage, the latency requirements, and so on. So don't, as an advice, don't wait for the hardware to be available in your hands. You can get started immediately with the great data set and with the Edge Impulse tool. But Thomas, if you want to comment on that.
Yeah, just a quick comment on the hardware. Of course, I already mentioned it's Arduino and Seed Studio have been generous to us to provide this hardware. So participants, once they apply, we are going to look at their justification as well as on if they really need the hardware for their prototype, because we have limited number of hardware. So we are also going to look into the proposals. If the proposal doesn't match with what they will, like if they say they are going to use Seed Studio hardware, but in their proposal there's no description of Seed Studio hardware, then there's no point to give someone hardware. So yeah, we'll look into those aspects.
That is an important hint right there. Thank you so much, Thomas and Marco. And once again, thank you for the support in getting the hardware for our teams. Jona, how many classes are in the outputs of the rain classes? Is this a regression to get specific values of rain intensities?
Okay. So for the reference weather station, what we actually get is we have a bucket where we can fit in water. And every time the bucket is filled, the bucket flips and it generates like one interrupt that we detect. And so the output of like the reference system is really how many interrupts in every packet. So for example, if in the current packet, the bucket flipped one time, then we will put this count to 1, otherwise it would be put to 0. So it's up to the participants to then convert this to an intensity. So basically, if you have like an interrupt every minute, for example, based on the documentation that we wrote, we specify how much millimeters water there is in that bucket, and then you can calculate the intensity of rain during that period. And then the participants can choose whether to go for a classification case where you basically bundle the rain intensities in a certain zones, and then you try to classify in these zones. And this is probably the easiest way to get started, to go for a classification task instead of going for a regression where you really try to estimate the exact value of the rain. Because in the end, if for the final application, usually it's sufficient if we can just classify in a couple of classes. But for example, 5 to 6 classes, this would be ideal. Yeah.
Okay, yeah, thank you so much. Energy consumption. So yeah, so energy consumption, you talked about energy consumption. How would you measure energy consumption for these models, please?
Yeah, so for the energy consumption, because every board can be different, so every board is different, the consumption of the boards are different, so this is difficult to compare. So therefore, what we are going to do, we're going to analyze your model and analyze the number of operations it requires to do one inference step. And then this is a measure for the energy consumption.
I see. Okay. Just to check, is this already in your documentation? You have already, I mean, somebody's participant, if they read the documentation, is it already captured there?
So for the evaluation, we didn't put a lot of details yet, but this will be published throughout the challenge. So check out the portal from now and then. But if we will do important updates, we will also let you know by email.
Cool. Okay. I want to maybe ask Thomas about our opportunities and our experience from the summit presentations. Thomas, we had summarized, and we had also hosted the first prize from the last year's challenge. Could you summarize your experience from the summit, please? I mean, with respect to with respect to the tinyML.
Yeah, so it was really interesting to have CSEM in our, I would say, AI for Good summit in July. They had exhibition booth for the 2 days, but also at the same time we had a tinyML session that we managed to present activities related to tinyML. Evgen was there, who is the board chairman of the tinyML Foundation. And the plans are underway that we have a much more bigger role in the AI for Good Summit next year. So we hope with this competition, but also other activities happening in the tinyML space, tinyML community space, we have more participation. I hope we can invite the winners next year to join us at the AI for Good and present their solutions. But of course, it depends on the quality of the solutions that we have and the impact that it can make.
Thank you so much, Thomas. So if I were a participant, I would listen very carefully to what the mentors told today. I mean, both Thomas as well as Jona, Matteo, and Marco. They told us that we have not only prizes to look forward to, but there are other opportunities as well, and also the phases of the project where proposal is important to get support from this as well. Thank you so much for answering all the questions very patiently. Back to you, Thomas and Marco, for closing. Thank you.
Thank you very much, Vishnu, for the Q&A. I think that was smooth. We are almost on time. So at this point in time, I would like to thank all the speakers, Marco, Jona, and Matteo, for taking your valuable time to spare and join the session today to prepare and to speak. So we have 3 problem statements that you can participate. The registration is open. You can join at any point in time. You can create a team. You can inform your colleagues in the network to join to create teams. We have next generation tinyML smart weather station, scalable and high performance tinyML solutions for plant disease detection and wildlife monitoring. 3 great problem statements that you can participate in. Interesting prizes. You have opportunities. You can use the Edge Impasse to start working on your solutions. For some teams, we'll receive hardware support. So many nice opportunities that are there. We'll be sharing information on some webinars, some communities that you can check out on resources as well. If you have extra resources that you want to share, for example, open datasets that you think can be useful for the community, please do share with us and we'll put it on the portal for everyone to utilize these resources. So we have more webinars at the AI for Good. You can check our AI for Good page, program page. We have several sessions that you can participate in. We have other competitions going on at the moment. So we have the Machine and 5G Challenge. That is a different competition altogether that is going on with several problem statements. We have the tinyML Challenge that is on, we have spoken right now. Of course, we have 3 problem statements ongoing. We have the GeoAI and several other challenges. So you can join, you can compete and win very interesting prizes. At this point, I'd like to thank everyone who joined the session today. Thank you so much, and I hope I can see you some other time. So from me and everyone else, I would like to wish you a very good day. Bye.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good. you.